Good day, people. Today's math model semester 2 lesson is 4.1. What is statistics? Let's get started. Okay, so this should be a very quick lesson. It's just the introduction. And I like these notes because they actually have the page numbers on it. You notice that the page number here, 1, 2, 3, 4, 5, and so on and so forth. So that's a big plus for these notes. So I like these. They're going to go really quick. So let's get started. It says, page 1, often you make choices by collecting data or considering information that someone else has gathered. That process is the foundation of statistics. Okay, page 2 says list the 3 parts of the process of investigating questions using data. So the first thing you want to do is collect data. The second thing is describe the data. And the third thing you want to do is make an inference. That's those 3 things written down. You want to collect the data, describe the data, and then you want to make an inference. An inference is kind of like your conclusion. So the next page says a table is the best way to display the data of different types. So on that line, you want to put table. And when they say table, they're really thinking about charts. Now, the good thing about this lesson, it does go really quickly. You may want to go ahead and check out the notes on Apex because the background information is that say you're a student and you're receiving college information. So they're basing everything on choosing the right college. So let's keep going. The third step of the data analysis process, using the data to make a decision, involves inferential statistics. Okay, and just like before, I'm going to go ahead and draw an arrow because that word inferential should be on that line, but we didn't have no space. So the decision that comes from the inferential statistics, the gathering of data and making an inference, is the prediction. So what you predict to happen. Okay, so now that we got those things written down, page 7 says fill in a table below with 3 examples of populations and samples of these. Page 10 on Apex does give a good matching of samples and population, so I'm actually going to go with those. So they would consider the population as being all of the faculty and staff at MHS, and the sample would be just the math department. Okay, another population could be all the citizens of America, but a sample of that would be just your registered voters. Okay, and a population could be all religious people, but a sample will be just the Baptist people. Okay, just to drive the point home, when we're looking for a sample of a population, statistics is a lot about collecting data and want to know everything about every little person. So when you don't have time to interview a whole population of all the teachers on campus, all the citizens of America, all the religious people, because we would be forever trying to figure that out, like what their opinions are, we can, instead of doing listening to the reviews of every teacher on campus, let's say we just go with the math teachers. Or another sample could be just the science teachers or just the English department. You get it. All the citizens could be the registered voters. Another example could be all the students on campus. It's about 3,000 of y'all. So it would take forever to get an opinion of every single person on campus. So instead of interviewing 3,000 different students everywhere on this campus, we could just say, let's talk to the Ignite kids. Okay, so that's the difference between a population and a sample. And that's why it's so important in statistics that sometimes we do look at samples. Okay, so let's say we are looking at those samples. The difference between the data from 2 samples is called sampling variability. So let's write that down. Okay, and sampling variability is just a natural occurrence in the data analysis process. Sometimes, okay, so page 9, and this is a straightforward one. It just says circle your answer. So if sampling variability of multiple samples is very blank, it might be a good idea to reconsider the samples. So in this case, if the variability is large, then we may want to go ahead and consider some other samples. And a good example of that is on page, let's see. Hold on. It's on page 9 inside of the Apex thing. Something else that you may want to look at is page 6. It says identifying a step. You may want to be able to determine where we are in the data, in the process of investigating data. Okay, so as always, this is a real short one. So Ms. Gable loves you very much. Remember that I am here to help you. I want you to consider doing the checkup practice problems, and if you have any questions, just let me know. I am here for you.